Now we'll find the total distance covered in this graph. It's a velocity time graph, and we'll find the total distance. To find the total distance, first we have to mark the graph. So from 0, the motion is here, then it went here, and it slowed down. So this entire area will give us the distance covered. So the total distance will be area of OABC. Now OABC is a trapezium. So we need to use the formula for trapezium. So area of trapezium will be half HA plus B. Now what is the H? The H is this height, is the distance between the two parallel sides. And remember, these are the two parallel sides. This is one parallel side here, this one, and this is the other parallel side. And the distance between them is H, here, this H. And we know H is 4.6. So here when we do half, and our H I'll put in red, that's how it is there. And let's see what is A and B. This will be your A, this will be A here. This will be A, and this will be our B. This entire thing will be the B. So this is my B now. So we have A, which we'll mark here. This is A, and plus the B is in gray. So this is area of trapezium. So look up there and see what is your H. We saw that the H is 4.6 meters. We have seen now what is A? Now let's mark what is A. See, A is between, this is A and this is B. So to find A, we have to do, see, this is at 10, this A here. See, this is 10 here, 10 minus, and this is 2, 10 minus 2. So A is 8. So we put A is 8. And to find B, now B will be from this point here to this point, and that is 6. So the B is equal to 6. And so now we find area is half H A plus B, which we have found the values. Half H is 4.6, 8 plus 6. And we need to work this out. So when you cancel, this becomes 2.3, and this is 14. And you know the area is equal to distance. So your distance, the total distance covered in this case will be 2.3 into 14. And that is 32.2 meters. So we found the distance by finding the area of this trapezium. Here we found the total area. And the next time again we'll find the total distance. So to find the total distance, let's go up and see the initial point here, and then the final point is here, and then the object has moved along this. This is the graph, velocity time graph, this whole thing. So the area between the velocity time graph and the time axis gives us the distance. So this entire area will give us the total distance. So distance will be equal to area of OABC, which is a trapezium. So we need to use formula for trapezium. So to find area of OABC, trapezium, half height of the trapezium, sum of the parallel sides. So let's mark. This is the height of the trapezium, and that is H, and you know it is 6. The height of the trapezium is 6, which are its parallel sides. This is one parallel side, and we will mark it as A, and the other parallel side is this one. These are the two parallel sides of the trapezium, and we will mark this as B. Now we need to find A. To find A, here this is A. Now A will be this point here. You see it's 12, 12 minus this point. At this point is 4, so 12 I don't think it's 12, it should be 10. I think if you go straight down you reach 10. It was not proper what I did. So it will be 10 minus, to find A, your A will be 10 minus this 4. So your A will be 6. Now to find BB is quite simple. It's straight on. It is 16. Have you seen B? B is this whole thing, and that is 16. So that is 16. So we have half. We saw our H was here. That is 6. Then we had A. Just put our A was here. We found 6. A was this part. It was 6. It was 10 minus 4, and that is 6 plus B. Our B was here 16. So that is equal to half into 6, and that is 22. So half into 6 into 22, and when you do this becomes 11, and this is 6 into 11, that is 66 meter square will be the total distance covered. Distance, which was the area of the trapeziums. So just to summarize it, for area of trapezium, if this is a trapezium, the area you find, this is the height h, and the two parallel sides, this is one parallel side here, and we have the other parallel side here. We'll put it in another color here. These are the two parallel sides, and the trapezium will be half H A plus B. This is wrong what I've done. This is not meter square. Distance is to be only in meters.